Hello, my name is Bhavin Shah, and I'm a Senior Technical Marketing Manager with Portworx by Pure Storage. In this lightboard video, we're going to talk about how organizations can build Retrieval Augmented Generation models or RAG models to make sure that their LLMs don't hallucinate. I know that was a lot of jargon. That's what we are going to break down in this lightboard video. So let's start by talking about large language models or LLMs, right? There are a lot of open source LLMs, and then there are like enterprise or closed source LLMs. But if you ask them specific questions, they do a good job at answering them based on the training data that they were trained on. But if they were not trained on domain specific information, they would give you false or incorrect answers and portray such that they were experts in those domains. We definitely don't want that when you're like, let's say if you are a lawyer and you were looking at case law and you were asking it to cite a specific case. You don't want it to make up citations. You want to make sure that the LLM app that you're using, the LLM based app that you're using, is using actual information or actual historical case data to give you answers. So one way organizations are doing this is by fine-tuning. Like they're taking an existing open source models and then they're fine-tuning it down to a specific domain. This can take a lot of time and a lot of GPU resources. And then once the model is published to a production setup, as soon as that happens, the accuracy starts deteriorating, right? Like you won't have information that's available in the data set after that model had hit production. So fine-tuning is definitely one way, a bit expensive, not 100% accurate or not 100% up-to-date. The other way to do this, or how organizations are trying to solve this hallucination problem, is by using the RAG model or the Retrieval Augmented Generation model. In a RAG model, organizations take an open source LLM that's available on repositories like Hugging Face or GitHub or their own repos, download them, and then they are feeding them information, domain-specific information from a vector database. So in this video, what we are going to talk about is how you can do all of these operations or build this architecture on a Kubernetes cluster. So for this video, we already have deployed a Kubernetes cluster. We have a set of compute nodes that are responsible for running our non-GPU based workloads. And then we have a set of GPU nodes that will be responsible for serving our large language model because they need a lot of GPU resources or GPU horsepower. On the compute side, and then we also have Portworx installed, right? On the compute side, we have installed the NVIDIA device plugin. And this plugin allows users to share GPU resources, right? And they can do this by one or two ways. The first one being time slicing. So instead of breaking down your GPU into multiple smaller chunks, you can give access to the entire GPU to a specific data scientist or a specific application or an LLM model, and they can share it for a specific interval of time. And then other users can do the same for the future time slots. Or if you wanted to go down the second route, which was, let's break down the entire GPU that we have and then make sure we can share it across data scientists. So these are some of the capabilities that device plugin brings to Kubernetes and makes it resource efficient and allows multi-tenant applications or multi-tenant models to be run on Kubernetes. We also deploy a kubeRay operator. So kubeRay is an open source project that allows organizations or administrators to offer Ray clusters or Ray jobs or Ray services as a service to their data scientists. So Ray clusters allow you to curate your data. Ray jobs allow you to like train or fine tune an LLM, and then Ray serve basically gives you the ability to download a model from a repository like Hugging Face and then run it inside your Kubernetes cluster. So this can be your LLM that's being deployed by the kubeRay operator as a custom resource, and that you're actually pulling down that model from a Hugging Face repository. To build the Retrieval Augmented Generation piece of this architecture, we'll also deploy a vector database. And a vector database allows you to provide like semantic search capabilities for your large language model. So instead of storing relational information or document-based information, you are actually storing information as vector embeddings, and then you can perform nearest neighbor searches to give you the closest approximation. So let's take an example, right? Let's go back to the same the law firm example. If I'm building a RAG model for my law firm, I'm downloading a chat-based LLM model from Hugging Face, and then inside my vector database, and again, vector databases can be existing databases like PostgreSQL with the PG vector add-on that gives that vector semantic search capabilities, or the latest version of Cassandra already has this capability built in without having to install additional extensions or components. But you can run these vector databases on top of your Kubernetes cluster using existing operators and get all the features that Portworx brings to the table for running those databases on Kubernetes as well. There are also newer database vendors that have come into the ecosystem that offer services like PineConeDB, VV8DB, that are also getting popular for retrieval augmented generation models. So once you have deployed your vector database on Portworx on Kubernetes, you can connect it to your large language model. So whenever your LLM application, so let's draw that out as well. Whenever your LLM application wants to fetch some data or ask the large language model to generate an output, it sends in a prompt. And then again, people already familiar with how OpenAI ChatGPT works know what prompts are. It's just a set of input text that you are providing to the large language model, which it uses to give you an output text. And this can be tokenized and broken down into separate tokens as well. Once your LLM receives this prompt, instead of generating output based on the training data it had, it actually goes and looks at vector database for a more domain-specific knowledge and treat it as a more domain-specific knowledge set. And before returning the output, it finds the closest answer that's relevant to this specific question, and that's what it responds to my LLM. So by building this retrieval augmented generation model, organizations can avoid hallucinations. And the benefit of doing this on Kubernetes and on Portworx are a few things. So let's talk about the benefits. First one being portability. We all know that GPUs are hard to find, and even if you have the budget and the resources to acquire those, you might face a backlog on when those GPUs actually get delivered. The way organizations are working around this issue are by renting GPUs from major cloud service providers like AWS or CoreWeave or Azure, and using that as a service, like infrastructure as a service resources. But that's what you're doing right now, right? Maybe 6 months down the line, you get those GPU resources inside your own data center and you want to run everything on-prem. By building your RAG models on top of your Kubernetes cluster, you make this portable, or you avoid any sort of vendor lock-in. You can take this same architecture and bring it on-prem and continue using your application inside your own data center. The next one being flexibility and scale. So because of the way the device plugin from NVIDIA works, how it allows you to share your GPU resources, because of the way open source projects like Carpenter or InstaScale from Red Hat and IBM Research work, they allow you to add GPU-based nodes and scale your compute capacity on demand when you actually need those resources for your LLM models. When you don't need those GPU resources, your infrastructure can scale down on demand, thus saving you costs as well. So cost becomes an important benefit, especially when you're doing this in the cloud, right? You don't want to have GPU-based nodes that you're paying for and you're only using it maybe a couple of hours a day. That's not the best resource utilization, and you'll end up burning through your budget. Because of benefits like portability, flexibility, scalability, and cost savings, organizations are choosing Kubernetes and Portworx to build retrieval augmented generation models where they can avoid hallucinations by using vector databases. That's it for this video. Thank you for watching.